Hello everyone. So here we are going to look at the solution for tutorial number 6, where we ask you to solve the electronic circuits given here using the matrix method. So here you will see that using matrix is going to be is going to simplify this problem a lot. If you try to solve this using the conventional method, then it's going to take a long time. So if you look at my notes, you will realize that there are two ways, one which is using the approach number 1 and the other one is using approach number 2. So here what I'm going to do is to show you the approach number 2 because this is rather straightforward. Right, so let us go to this. So in order to solve using the approach number 2, we are going to consider 4 loops over here. So this is going to be loop number 1 here, and here is going to be loop number 2. So this is loop number 3, and then this is loop number 4. So if you look at here, the first loop you have voltage, the input voltage, which is 20, but in the other loops, the V, that is the input voltage, is going to be equals to 0. So now the main issue is how to set up the matrix to represent the resistance at these 4 loops. So that is what we are going to look at in the following slide. Right, so now how do we set up the matrix is going to be like this. So this is the resulting matrix, but we will look at how we get this. Okay, so the first thing that we need to do is to build the diagonal matrix, right? So the diagonal elements. So what we do is this is let's say we are arranging our column matrix for the current such that we have I1, I2, I3, I4. So that is the premise that we're going to use in order to build this square matrix. All right. So the first term here, which this is let's call this matrix to be the R matrix. R standing for resistance, and this is going to be R11. So this is the resistance that is going to be felt by the current number 1. So the current 1 is going to be on this part, and the only resistance that you have is 2. So this is going to be 2. Then we go to the next one, which is the next diagonal element is going to be R22. So 22 is the resistance that is felt by the current number 2. So the current number 2 is over here. So this is the total resistance is going to be 5 plus 7 plus 2, and this will give you 14. Right, so we go to the next one. This is the resistance for the third loop. All right, the third loop is over here. So this is going to be a sum of 9, 6, and 7. So this is going to be 22. And the last one, which is the resistance for the loop number 4, over here, this is 9. Right, so now what we have done is we have built the diagonal elements, and now we can proceed to the non-diagonal elements. So the first thing that we will look at is the this one, for example, R12, the row number 1, column number 2. So R12, and this is R21. So this is basically the sum of resistance shared by the current number 1 and current number 2. So if you look at here, the resistance that is shared by current number 1 and number 2 is just this guy here. So this is going to be 2. But then in order to build this matrix, we have to put a negative sign over here. So 2 is coming from here, and then we add on the negative. So the R12 and R21 is the same. So you have negative 2 over here and negative 2 over here. Then we go to the next one. Here, this is R13, and this is R31. So the sum of resistance shared by current number 1 and number 3 is going to be here. If you look at this, current number 1 is over here, number 3 is over here. So they do not share any resistance. So therefore, it's going to be 0. So the same for over here, R14. R14 is over here, the resistance for shared by the current number 1 and number 4. So there is nothing here. So therefore, this is 0. So that is how you build this matrix. So for the last example, I just use this guy here, negative 7, and this one negative 7. So this is going to be R23, and this is going to be R32. Okay, so R23, R32 is going to be the total resistance shared by the current number 3 and current number 2. So where is our current number 3 and number 2? They are over here. So the only resistor that is shared by the two of them is this guy. This is 7, therefore we have negative 7. Right, so that is the same for over here. So that is the matrix that you have for the resistance. And then we can write the equation, the matrix equation like this. So this M, this shouldn't be M anymore. So let me just change this to R. So this is going to be IR. This is equals to V. So 20, 0, 0, 0 is because we have 20 for the current number 1 here, and the others is 0. So you have this column matrix. And in order to find this I1, I2, I3, I4, you just have to find the inverse of R, bring this over here, multiply them, and you will get this answer. Okay, so this is the answer for I1, I2, I3, I4. Now, if you want to find the current that goes through each resistor, you have to do the third step. Okay, this is step number 2. In order to find the current through each resistor, you have to go to step number 3. That is you are going to look at the sum of the current in that particular resistor. So take for example, this resistor over here, this is I1. I1 is coming from the top, and you have I2 which is coming from the bottom over here. So you have to take the difference between the two, I1 minus I2. So I1 minus I2 is going to give you 10 ampere, right? So this is going to be 10. And then the remaining will be the one that is going over here. So this is going to be the same as I2. So I2 is going to be 2.156 ampere, the current that goes through here. Well, for the current that goes through this 7 ohm over here, you have to look at the difference between I2 and I3, because I2 is coming from this direction, I3 is coming from this direction. So at this point, they are going to be on the opposite direction, so you have to take the difference. So 2.156 minus 0.838 is going to give you a net current that goes in this direction from the right to the left. Okay, then the last one, the last two will be here. I3 basically is 0.838 only, so this is straightforward. And the same concept applies to the current that goes through this circuit and this circuit, this resistor and this resistor. So here this is straightforward also because I4 is immediately you can get it from here. So this is 0.559 ampere, and over here the current that goes through the 6 ohm is going to be a difference between I3 and I4. So you have to take I3 minus I4. Right. So basically that is how you solve this this electronic circuit problem using matrix, which as you have seen, this is very simple. Using matrix, you can solve it very easily. Right, so I hope this would give you an idea how to use it in other applications in the future.